Here's another example from chapter 18. It's very similar to the first example. So here, this is kind of funny. We don't know it, but 52% of voters plan to vote yes on the upcoming school budget. Okay, that's kind of funny because now we do know it. We poll a random sample of 300 voters. What might the percentage of yes voters appear to be in our poll? Okay, so let's just take a couple quick notes. First, our sample size, n, is equal to 300. And the true population proportion is not p hat. I always want to put the hat on there, but it's not p hat this time. Okay, this is kind of an artificial situation. It's 0.52. Okay, so what we would like to do, once again, is draw a model, and I just try to focus on this just for a second. Something like this. So we already know that the center is going to be 0.52. If you think about what the variable is here, the variable is, so this is P, the true population proportion, but the variable is p hat. We really want to know what can we expect if we do a sampling of 300. Okay, so let me label where the standard deviations would hit. 2 and 3, something like that. So we'd like to be able to label these and then explain. What would we expect 68% of the time? Okay, and what would we expect 95% of the time? And so on. Okay, so to do that, we have to check the conditions. So the random sample condition, so let's see, we pull a random sample, so yes, they pulled a random sample. I can't live with that. They pulled, I can't live with that. They pulled a random sample. Okay, so that's good. And we're going to assume that 300 voters is less than all the voters, which is true, providing the population of voters is at least 3,000. Okay? So then the success failure condition, we want to check if NP is greater than or equal to 10 and is NQ greater than or equal to 10. So our sample size is 300 and we're going to multiply that by 0.52. So that's, if I cheat, that's approximately 150, and that's greater than equal to 10, right? 50% of 300. And in here, 300 times 0.48, and again, because I want to go fast, I'm going to cheat and say that that's approximately 150. So the sample size is large enough. Okay, so now we can, the conditions are met, conditions are met. So we can use a normal model. Remember, the notation we use is n, mu, and sigma. So for this particular model, mu is equal to the true population proportion, and the standard deviation is going to be this formula, the square root of p times q over n. Okay, so this is going to be 0.52, and let's just say the standard deviation of p hat, so what we expect if we took a sample is 0.52 times 0.48, all divided by 300. Okay, and with that I get 0.029. Okay, so with that I can now label my model. This is going to be 0.549, and that's going to be 0.578, and this is going to be 0.607, and then if I subtract, this is going to be 0.491 and 0.462 and 0.433. Okay, so according to the model, what can we say? We expect 68% of the samples of 300 voters to have proportions of yes votes 49.1% to 54.9% of, I want to say of the time. I don't know if that makes sense. Time. Okay. We expect between 46.2 and 57.8% yes votes, 95% of the time. And finally, we expect between 43.3% to 60.7% yes votes, 99.7% of the time. Okay, so something like that. I'm sure you could probably write even better than me. So anyway, there's how you do this problem. It's a little bit artificial because we're being told what to expect. We're actually being told what the model is. But there you go.